As the enterprise infrastructure has evolved, so have Ethernet switches and routers. Multi-layer switches which combine both routing and switching functions have become increasingly popular. A multi-layer switch, commonly called a layer 3 switch, is a high-performance solution that provides an ideal core or distribution layer function in the enterprise. The performance of the switch is provided by the hardware ASICs, which are responsible for the rapid header rewrites and forwarding. The ASICs which reside at the interface level also substantially offload the main CPU. A multi-layer switch maintains two main tables that are used in the routing and switching processes. These tables are known as the CAM and the TCAM table. The CAM table is comprised of layer 2 information and keeps a record of MAC addresses and the ports they're associated with. A typical switch performs what we call MAC-based learning, which is a process that populates the CAM table as each device on a given port generates traffic and the switch learns its MAC address when it sees the traffic. The TCAM table is comprised of layer 3 information, which includes access control list, ACLs, and quality of service, QoS, configurations. The ACLs are used to define interesting traffic and can be used for a variety of purposes, including security, traffic direction, and QoS. ACLs can be used as a part of the mechanism to permit, deny, classify, and mark traffic to secure, optimize, and protect network traffic. Incoming frames can be classified according to QoS parameters, and the traffic can be then prioritized and rate limited. QoS decisions are also made by the TCAM in a single table lookup. Traffic going through a layer 3 switch will be pulled off an ingress queue, which uses the CAM and TCAM to determine if the frame should be forwarded. If it meets the criteria to be forwarded, the next decision is to use the tables to determine where to forward the traffic. Finally, the QoS information will be used to determine if the traffic will be forwarded with certain priority and markings. After these processes are complete, the traffic will be placed in the egress queue and then transmitted to the next device on the network. The multi-layer switch is an efficient device at obtaining next hop information from the forwarding information base, or FIB, and reading and rewriting the parts of the frame that change as necessary to reach the destination. The MAC source and destination address will be updated by the switch as traffic passes through it. The incoming frame will have the destination address that belongs to the layer 3 switch. The source address will be that of the device that sent the frame. As the frame leaves the switch, the header will be rewritten, and now the source address will be the layer 3 switch, and the destination will be the address of the next device as determined by the TCAM and CAM table lookups. Cisco Catalyst switches can support both physical and virtual interfaces. On a layer 3 switch, a switched virtual interface, SVI, can be utilized to map an IP subnet to a VLAN. The SVI can also serve as the default gateway to provide the mechanism to route traffic from one VLAN to another. The ability to route between VLANs on one device illustrates the benefit of using a multi-layer switch. Both layer 2 and layer 3 are cached in hardware and forward frames and packets using hardware ASICs.